Have you ever heard of Yellowstone? It's a huge, amazing park in the United States, famous for its geysers like Old Faithful that shoot hot water high into the air. But did you know that underneath all that beauty, there's a giant, sleeping volcano? A supervolcano, to be exact. And sometimes it gets a little rumbly. Today we were going to dive into what's really happening beneath Yellowstone when the ground starts to shake. Imagine you're holding a soda bottle. If you shake it, all the fizzy gas inside gets stirred up and pushes against the bottle. Yellowstone is kind of like that, but way, way bigger and much hotter. Deep underground, there's a massive chamber filled with hot, gooey, melted rock called magma. This magma is always moving around like a slow-cooking soup. Above this magma chamber, there's a network of cracks and pipes, like a giant plumbing system. Hot water and steam from the magma travel up through these pipes. This is what powers all those cool geysers and hot springs you see on the surface. Now let's talk about earthquakes. An earthquake is just the ground shaking. In most places, earthquakes happen when giant pieces of the Earth's crust, called tectonic plates, grind against each other. But in Yellowstone, it's a bit different. The shaking is usually caused by all that action happening underground. Think about our soda bottle again. As the pressure builds, it can make the bottle creak and groan. In Yellowstone, the movement of magma and hot water pushing through those underground pipes can cause the rocks to crack and shift. Each little crack and slip creates a small earthquake. Sometimes, instead of just one or two small quakes, Yellowstone experiences something called an earthquake swarm. This sounds dramatic, but it's actually pretty normal for this area. An earthquake swarm is when a bunch of small earthquakes happen in the same area over a period of time. It could be hours, days, or even months. It's like a popcorn machine, where you don't just get one pop, but a whole flurry of them. Scientists at Yellowstone see thousands of these small quakes every single year. Most are so tiny that you wouldn't even feel them if you were standing right on top of them. They're detected by special supersensitive instruments called seismometers. So, what causes these swarms? There are a few main reasons. One major cause is that hot water and steam moving around. As this pressurized water squeezes through tight spots in the rock, it can force the rock to fracture, causing a tiny tremor. Imagine trying to force water through a kinked garden hose. It puts a lot of stress on the hose. Another reason is the slow movement of magma itself. As the magma shifts and pushes from below, it puts stress on the crust above, causing it to crack and settle. It is like when you have a big stack of books and you pull one out from the bottom. All the other books have to shift and settle into a new position. That's what's happening with the rock layers above the magma. A third reason is related to old cracks in the rock, called faults. Changes in pressure from the water and magma underground can cause these old faults to slip a little, creating a series of small earthquakes. Think of it as the ground just adjusting itself to all the underground activity. It's Yellowstone's way of letting off a little steam. Now the big question everyone asks, does an earthquake swarm mean the supervolcano is about to erupt? It's a great question, and the simple answer is, almost certainly not. Scientists who study Yellowstone 24/7 say that these swarms are just part of the park's normal everyday life. For a massive eruption to happen, we would need to see a whole lot more than just a typical earthquake swarm. What would those signs be? Well, first, the earthquakes would need to get much, much stronger and happen much closer to the surface. We're not talking about the tiny tremors they usually see, but big quakes that you could actually feel. Second, the ground itself would start to change shape dramatically. The land would bulge upwards by many feet, not just a few inches, as a huge amount of magma surged towards the surface. Third, there would be massive changes in the geyser and hot spring activity. We might see new steam vents opening up, and the temperature and chemical makeup of the gases coming out of the ground would change significantly. Think huge clouds of sulfur-smelling gas. So an earthquake swarm on its own is like a little sneeze from the volcano. A super eruption would be preceded by a massive, prolonged fever with all sorts of crazy symptoms. Scientists at the Yellowstone Volcano Observatory are constantly monitoring everything: the ground shaking, the land deforming, the gases, and the water temperatures. They have an incredible network of instruments all over the park, and they would know far in advance if something truly big was brewing. They've seen many earthquake swarms over the decades, and none of them have led to an eruption. In fact, the last super eruption at Yellowstone happened over 630,000 years ago. and the last lava flow was about 70,000 years ago. These earthquake swarms are just a sign that Yellowstone is a living, breathing, dynamic system. It's a natural laboratory where we can learn so much about how volcanoes work. The constant rumbling and shaking is the heartbeat of this incredible place. It's what makes Yellowstone so unique and special. It's a reminder that the Earth is always changing, always moving, and full of incredible power and wonder, right beneath our feet. So the next time you hear about an earthquake swarm at Yellowstone, don't picture a doomsday movie scene. Instead, picture that incredible underground world of hot rock and water, just shifting around and doing its thing. It's the park's natural rhythm, a sign that the giant is just stirring in its sleep, not waking up. Thank you so much for joining me on this journey deep beneath Yellowstone. I hope this helps you understand the rumbles of our planet a little better. If you enjoyed this video and learned something new, please give it a thumbs up, and don't forget to subscribe and hit that notification bell so you won't miss our next adventure. See you next time.